Good morning. Today we are going to study about basic definitions and elements present in electrical circuits. Charge is the basic definition in electrical circuit. The characteristic property of any elementary particles of matter is called charge. Unit of charge is coulomb and it denoted by the letter Q, capital Q or small q. Atom consists of positively charged nucleus and negatively charged electrons. And second one is the current. The rate of flow of electrons is called current. It is denoted by the letter I. The unit of current is ampere. I equal to charge with respect to time. Next one is voltage. Voltage is defined as the ability of charged body to do work in moving and cooling off charge between 2 points. Voltage V equal to W by Q. Next one is power. Power is defined as the ratio of work done to the time taken or the product of current and the potential difference. Power equal to V into I or work done with respect to time. The unit of power is watts and it is denoted by the letter is W. Next one, energy or work done. Work done is defined as the capacity to do work. It is denoted by the letter W. Unit is joules or Newton meter. Energy is the product of power and time. W equal to P into T watt second. The basic elements of electrical circuits are two types. One is the active element. Second one is the passive element. Energy storage devices, that is the source of energies, are called active elements. Example, voltage source and current sources. Generators, transistors, vacuum tubes are called as energy sources. Then what is meant by element? Element or a device or the two-terminal device, which are the basic building blocks of the electrical circuit. For example, active elements, voltage and current, both of them having two terminals. Then second, passive elements. Passive elements stores energy or dissipate energy in the form of heat. Resistor, inductor, capacitor are called passive elements. Out of three passive elements, inductor and capacitors are energy storing element. Resistor is dissipating energy or dissipates energy in the form of heat. So all these elements having two terminals, it is connected in the circuit. So it is the building blocks of the electrical circuit. First one, resistor. Resistor is the property of material to oppose the flow of current in the electrical circuit. It is denoted by the letter R and the symbol is shown in the figure. The unit of resistor is ohm. R equal to rho L by A. Then second passive element is inductor. It is a property of a material which stores the energy in the magnetic field. It is denoted by the letter L. The unit of inductor is Henry. L equal to N pi by I. L is the self-inductance of the coil. N is the number of turns of the coil. I is the current flowing through the coil. Pi is the flux produced in the coil. And also the voltage across the inductor, V equal to L into di by dt. Current in the inductor equal to 1 by L integration of V into dt. The third element is capacitor or capacitance. So it is the property of the element to store the electric charges. So inside the capacitors, the electric charges are stored. The unit of capacitance is farad. The symbol is shown in the figure. It is denoted by the letter C. So C, the voltage across the capacitor equal to 1 by C integration of I into dt. Current through the capacitor I equal to C into dV by dt. That is rate of change of voltage. The next one is the electrical energy sources. There are two electrical energy sources. One is the voltage source and the other one is the current source. So voltage source is a two-terminal active element. So the first and second diagram shows the AC voltage source and DC voltage source. This first two diagram is the ideal one. So the input voltage is equal to output voltage. That is lossless circuit. The third one is the practical voltage source. So Vs is the source voltage, or S is the source resistor. So the source resistor is also called an internal resistance of the voltage source. If the voltage series with the resistance is called the practical voltage source. And second one is the current source. So first diagram shows the ideal current source. Second one is the practical current source. In ideal current source, the input current I equal to output current I. But in the case of practical current source, the input current I is not equal to the output current I. And also, the internal resistance Rs is present in the current source. That is, the current source parallel to the internal resistance is called as current source. So the second diagram is the practical current source diagram. Thank you.